Welcome to the second part of my talk, Why Do We Know Less About the Human Brain Than the Dark Side of the Moon, also known as The Life of Brian the Brain. So this is the second part of a talk which you can find the first part of also here on YouTube. First of all, I want to say thank you and welcome to people from all around the world that seem to tune into this the first time I gave this talk, and this is my welcome to all of you in your different countries. And this is a map of the different countries that people were tuning in from. If your country isn't shown here, then do get in touch with me and my team so that we can make sure that we include you next time. I'm going to start the talk with this fun little video from Monty Python's Life of Brian, and you'll see why this is important later on in the talk.
Now you listen here. He's not the Messiah. He's a very naughty boy. Now go away.
So for those of you who are old enough, you'll know that this is from this film, The Life of Brian, which is about a 30-year-old man in the Holy Lands whose friends think that he's the Messiah, and his mother is saying he's not the Messiah, but he's a very naughty boy. Well, I'm going to be telling you about a different 30-year-old, the Brain, who I'm going to call Brian, and I'm going to show you, hopefully, that he's not a naughty boy. He's actually an extremely intelligent boy, but just not well understood. In the first talk, I was showing you some patients that have been studied by different researchers around the world, and I wanted to just recap some of that. I told you about Philip, who had damage to what's known as the occipital lobes, which is in the back of the brain, behind the ear, and it's the red area here that you can see in the diagram. And Philip had damage to that part of the brain due to a car crash. And in the next video, we're going to see Philip in a zoo, and let's see what he thinks he can see.
One of the first things we learn to do is to recognize and name animals.
Camel. Camel? They're camels. I'll hazard a guess they're camels. Too late, giraffe. But if I hadn't seen the signpost, then I wouldn't have known.
So what we see there is that we have someone who is seeing what we know is a giraffe, but who doesn't understand that it's a giraffe and can't see it and thinks it's a camel. And what that tells us is that what we think is obvious is actually not that obvious. And in fact, our brains have to do a lot of work to work out that that is a camel. Sorry, a giraffe, not a camel. The next patient I want to tell you about is called David, who has a condition called prosopagnosia, and I talked about prosopagnosia a bit in the last talk as well. So David suffered from brain damage, and it nearly killed him, unfortunately. Thankfully, he survived from it, and in the brain scan here, this is as if we're looking down into his head with his eyes at the front, at the top of the picture, and his at the back of his head at the bottom. And you see that area of white which is on the right hand side of his brain, which again is behind where your ears would be, and that's the area of brain damage that David had. And in the next video I'm going to show David some videos, and let's see whether he can recognize this rather famous face in the video.
No.
Okay.
Is that Marilyn Monroe?
1 to 10?
I would say 7.
Okay.
Because of the little beauty spot and the red lips. Don't show red, but you can sort of...
Yeah, right.
I can imagine saying, "Happy birthday, Mr. President."
Okay. Now, what you see there is that David thinks, what you see there is that David looks at this photograph, first of all, of the then Prime Minister of the UK, Tony Blair, and doesn't know who it is, which is quite amazing because this was during the Iraq War and our Prime Minister's photograph was on the TV all the time. Then he sees a picture of Marilyn Monroe, which is one of the most famous photographs ever taken, and yet he doesn't realize it's Marilyn Monroe. He eventually asks whether it's Marilyn Monroe, but it doesn't actually say it is, and he's not even 100% certain. He says he's certain 7 out of 10, and he says so by looking at her lips, her hair, etc. So what we see here is that, again, something that we take very much for granted and we assume that it's Marilyn Monroe is actually not as obvious as we think. And again, that gives us a really interesting clue into the fact that the human brain is doing a lot of visual processing, and that is obviously disrupted here in David's case. Now I'm going to move on to human memory. Now, to increase the chances of survival, things that you've learned before and the knowledge that you had can be extremely beneficial, because then you don't have to learn everything new every day. So what did your friend just say to you 10 minutes ago, so that your friend doesn't get annoyed that you're asking them what they've said again? Have you met this person before? Are they a friend, or are they someone you have to be very careful of? How did you build that weapon that allowed you to defend yourself? Now, here I'm talking about the African savannah 100,000 years ago rather than current day London. This is because when we were little warring tribes, we needed to be able to defend ourselves, and we needed to remember these skills that we used all the time. Where was that food that I found last week? And again, this is back to the African savannah when we were hunter-gatherers, and we needed to know where the good food was, where the bad food was, or the dangerous areas. And you needed to know where you were and where the safe places were, etc. Now, all of these types of knowledge require a memory system to encode, which means to take in, and then to store that previous information so that when you need it today, right now, you can call it up again very quickly. And we know that the system has been developed because it can be selectively impaired, which means that it can be damaged whilst leaving everything else virtually okay, resulting in what's known as amnesia. Now, I'm going to tell you about a patient that I studied called Nicola. And Nicola unfortunately suffered from a nasty virus called herpes simplex encephalitis, which destroyed the major parts of her brain. And in this video, in this scan, what you are looking at is as if you're looking through Nicola's head with her ears to either side. So it's as if you're looking face onto her, but halfway through her head. That area of grey on the left-hand side that you see there is the area of brain damage, the dark grey. It should actually be more like the light grey that you see above, but the brain damage has left that grey area, which is actually brain damaged tissue. In the next video, I'm going to give Nicola a series of words, and then I'm going to ask her to recall these words immediately, straight after I've given them to her. Then I'll speak to her for about 45 seconds, and then I'm going to ask her for the words again. Then I'm going to do something, and let's see what happens. Okay, I'm just going to read out 8 words to you, and what I'd like you to do is to just when I'm finished,
repeat the 8
repeat
words, if I can remember them.
whatever you can. Okay, so are you ready? Okay. Table, lion, apple, shoe, carpet, robin, carrot, flower.
Table, apple, lion, shoe, flower. Can't remember anymore.
You did pretty well there. You got 5 out of 8. So.
I got about 4.
Well, you did better than Reg there, so well done. Okay, how are you at recognising people on TV? Do you watch much TV or films?
I watch television, don't I? And films.
Do you recognise the people on the film?
I don't know, do I?
Sometimes.
Sometimes.
What's your favourite programme?
EastEnders, I suppose. If we have it on.
So what's happening in EastEnders at the moment?
Well, I couldn't tell you.
Okay.
I'd have to wait for it to start and then
It comes back.
I think, oh, so.
Okay. I'm just going to go back to those words that I gave you. Can you tell me what words I gave you?
No, I can't.
You even remember one of them?
No.
Okay, now I'm just going to see how well the couch over there does. Okay.
Apple, lion, robin.
Robin, table.
I've got 4, you see.
That was 4 again, yeah. That was between 2 of you there.
Yeah,
Right, yes,
yeah.
Okay.
I've got 2, that's right.
Now, if you don't mind, I'm just going to go to the bathroom. It's
Right.
just near
Just
the door,
round
isn't
by
it?
the front door, yeah.
Okay. If you guys just want to talk about what you did in Spain.
What we did in Spain.
Yeah. Tell Nicola about what you guys got up in Spain.
Do you remember going to Spain? You only got back on...
No, I don't remember
Thursday.
Tuesday night we
Tuesday.
came back.
Hello, everybody.
Hello.
Hi, Ash.
Hello. Have we met before?
I don't think so.
No. My name's Ash.
And I'm Nicola.
Now, what you see there is an incredibly profound form of amnesia. And importantly, when I first give Nicola the words to remember, and I ask her to repeat them immediately, she remembers 5 out of 8. And you see that her husband, sitting nearby, who wasn't expecting to be tested, got 4 out of 8. The fact that Nicola got 5 out of 8 shows that her ability to take information in is completely okay. 5 out of 8 is what you would have got. If you got 6, you'd be doing quite well. If you got 7, you'd be doing really well. So 5 out of 8 shows that her ability to take information in is completely okay, and that's what we call short-term memory. Then I speak to her for 45 seconds, just about TV, etc., and we see that she's got nothing left after that. She remembers none of the 8 words, whilst her husband still remembers 4 out of 8. And that's a very profound form of amnesia, because she can take the information in and repeat it, but as soon as any new information comes in, which is the conversation that we're having, it's all gone. And then you saw that I went out of the room and came back literally 2 minutes later and introduced myself to her, and she didn't know that we'd met before. And again, that's a very profound demonstration of amnesia. So it's not that short-term memory is a couple of weeks, it's literally the last minute or so. Now, by studying people like Nicola and other patients who've unfortunately had very severe damage to those parts of the brain known as the medial temporal lobes, we work out that memory is not one thing, memory is many different things. So, memory breaks down at least between these 2 different types, short-term memory and long-term memory. So if I was to give you my office phone number, that would come into your short-term memory, and you could use that to write down my number as I was saying it to you. But that store of memory lasts literally a minute or so. It's not the last couple of weeks, it's literally the last minute. So even the video that you've just seen, if you can remember that, that is coming from long-term memory, not from short-term memory. We then know that long-term memory itself breaks down into 2 different types of memory. Procedural memory, which is memory for skills, such as playing a guitar or building weapons to defend yourself, and declarative memory, which is memory for information and facts. And that actually breaks down itself into two different types of memory. Episodic memory, which is memory for events such as birthdays, so this is my 50th birthday party cake, and pure factual information that you know about the world. So, for example, Einstein's famous equation. So what we see here is that by studying people like Nicola and other patients with different types of memory problems, we can understand that memory is many different things. And what we find out is that patients like Nicola have actually got intact abilities such as intact short-term memory and intact procedural memory. And we know this because of their performance on different tasks that we can create that show that even though the long-term memory is relatively damaged, there are some parts of it, such as the procedural memory, that are intact. Now, that takes me into a different form of memory problem known as dementia. Now, dementia is very different from amnesia. Dementia is a degenerative disorder. It's not like Nicola's, where she developed brain damage from this very severe damage to the medial temporal lobes. Dementia is a degenerative disorder where very slowly different parts of the brain start getting damaged, and we don't actually understand how that happens, and that is why a lot of research is needed. In this map of the world, we see the estimated number of people who are living with different types of dementia in 2015. So we see that in the Americas there are about 9 million people, in Europe about 10 million, but in Asia there are about 22 million people. Looking at the cost of the fact that people have dementia, caring for them, the loss to economies because these people aren't working, etc. In 2015, the loss to the cost of dementia globally was 818 billion. In 2018, so already 2 years ago, it had risen to 1 trillion. And by 2030, so less than 10 years from now, that's going to double to 2 trillion. So this suggests that there's a big problem that is in store for the world. And what we see here is the number of people who are living with dementia in different types of countries, and this is broken down into different types of incomes. So we have the high income countries, so Northern Europe, North America, etc. And we see that from 2015 through to 2050, there's possibly a doubling of people living with dementia. But we see that in the low and middle income countries, there are more people already by 2020, but by 2050, it's going to grow even more. And so we do have a bit of a time bomb ticking away here, which shows why we need to do more research to understand dementia so we can help these people all around the world. Now, in terms of trying to help people, one of the most important things is early detection. And we've seen this during the COVID pandemic, that we unfortunately know that people have got the virus because of them developing symptoms, etc. But the symptoms take a while to develop in COVID. With dementia, it takes even longer. And unfortunately, at the moment, by the time that clinicians know that someone has got dementia, it's almost too late, because by that point the disease is set in quite strongly. So one of the important areas of research at the moment is trying to detect dementia before those very obvious clinical signs have come in. And if we can find early ways of detecting dementia, then we can support the sufferers and their families and hopefully give them a better quality of life. So some of the research that I'm doing with my PhD student, Terry McGibbon, is that we've developed a new test called the VALMT. And in this, we teach people certain information, kind of like the way that we gave Nicola the words to remember, but a different type of test. And then we test people 5 minutes, 30 minutes, and 55 minutes after we've given them these words. And what we see with this is that young people, so let's say in their 20s, tend to forget a bit from 5 minutes through to 30 minutes. So there's a bit of forgetting, and that's completely normal because we do need to forget, actually. It would not be much use if last year was exactly as clear as yesterday. So a bit of forgetting is fine. Then we have a class of people that we can differentiate on our task that we're calling elderly A. And these elderly A's are not that different to our young 20-year-olds. They're only forgetting very slightly, and these are people who are completely fine in their 60s, who don't show any signs of forgetting, and they can go into their 80s, etc., with very clear memories. But there's another class of elderly people who are in their 60s who are performing very differently from other 60-year-olds. What we see is that even at 5 minutes, they're already performing poorly. At 30 minutes, they're performing quite a bit worse. By 55 minutes, they're performing extremely poorly. And some of these people have forgotten the majority of the information that we gave them less than an hour ago. And we think that these people, the elderly B, who are only in their 60s at the moment, although they are not yet suffering any major memory problems, in the next 5 years, they may suffer from dementia. So what we're hoping is that with this test, we're able to detect people a lot sooner than current tests are able to do so. If you're interested in this work on the VALMT, then please do get in touch with me, and we're happy to share our test with other people. Now, if we put together the different types of information that we get from testing patients like Philip, David, and Nicola, we're slowly able to understand what different parts of the brain are doing. Now, this image is actually three-dimensional images of my brain, and this is taken by putting together a lot of two-dimensional MRI scans and then creating a three-dimensional picture out of it. Now, what you see on the left-hand side here is my right hemisphere. So this is as if you're looking at me with my eyes here, my nose here, and the back of my head here. And this here is my left hemisphere. So again, my eyes here and the back of my head here. And what I've done here is to highlight, like a road map or an atlas, different parts of the brain and what we think they're doing. So, for example, this area here is the area that we know is important for recognizing people. And so that's my lovely family there. And this is the area that we know is damaged in David, the patient with who couldn't recognize Marilyn Monroe, etc. At the back of the brain, this area here, the visual cortex, is what we use for visual recognition of the world around us. And that is the area that is damaged in people like Philip, who couldn't recognize the giraffe. And we see other areas. The area where we appreciate music is on the right side of the brain. It's around here. The area that is important for speech and language is on the left side of the brain. It's around here. There's a strip, like an Alice band, that goes halfway down the brain over here and over here, which is for controlling the opposite side of the body. Then finally, the front of the brain, which is the brains of the brain, it's the manager of the brain, and it's important for decision making, for organizing some aspects of personality, and that is an area that I'll be talking about in a future talk. Now, an important thing about this is that these images were created in 1998, so 22 years ago. So this is almost a historic document because it's a form of cave art now, because so much more has been learned about the human brain in those 22 years. So in a way, this is going to be a historical document because we know so much more now. And this is one of the things about the area that I work in, that there's an enormous growth in our knowledge thanks to research. Now, up until now, I've been telling you about brain damage and the unfortunate and horrible things it can do to people's lives. Thankfully, because of the knowledge that we gain from studying people like Nicola, who you see here again, we're able to see that there are ways that we can help them, and that's the exciting field of neurorehabilitation. If you remember from that diagram of the memory system, I said that we could see that there are certain aspects of memory that are actually not damaged in people like Nicola, and one of them is procedural memory, which is the ability to learn new skills. In this video, my student Gail is with Nicola, and she's going to show her a palm top, which was a precursor to our modern smartphones. It was looked like a phone, but it wasn't actually a phone, but it allowed people to store information, reminders, etc. And Gail is going to show Nicola this palm top and just ask her whether she knows how to use it, and let's see what happens.
So, have you used this machine before?
I can't remember.
Don't recognise it?
I switch it on.
If you just wait a second before we
I switched it on, yes.
Yeah. So you don't recognise the machine at all, no?
Oh, no, not really.
No.
Now what we see there is Nicola saying, no, I don't know, I've never seen it before, and it might be the case that Nicola has never seen this before and she doesn't know how to use it. But let's see if that's actually the case. In this video now, Nicola is just doing some crosswords in her book, and we set the palm top. This was taken immediately after the previous video. We've set the palm top to do a reminder. Let's see what happens. And what I'd like you to do is to look at Nicola's face and her left hand, because it's rather important what happens.
Make a cup of tea. Do you want me to make a cup of tea?
Oh, would love a cup of tea if you don't mind. Do you fancy one?
Oh, I'd love a cup of tea, so what do I do now? Dismiss it?
So what we see there is that Nicola had claimed in the previous video that she'd never seen a palm top before, and she certainly didn't know how to use it. And yet, when the palm top started ringing, she didn't even look up from her book. Her left hand just reached out, picked up the palm top and flipped it open. Now you'd need to know what to do to be able to do that. So despite the fact that Nicola said she didn't know how to use it and had never seen it, we can see in her reaction to just picking it up without even looking at it and flipping it open that she actually does know how to use it. Now the reason for that is because we'd spent 4 weeks teaching Nicola very painstakingly, very slowly, using this intact procedural memory, how to use this palm top. And the important thing is that she doesn't need to be aware that she's learned it, as you saw in the video, that she said she didn't know how to use it, she'd never seen it. She doesn't need to have an awareness of that. As long as we can get into that intact procedural memory, we can actually teach Nicola new things. And that is one of the wonderful, exciting new areas of brain damage, that we're able to harness these intact abilities. Now, having talked about brain damage, I'm now going to move on to the healthy brain, because our understanding of the brain is not just about brain damage, it's also about the intact brain. I'm going to show you this wonderful quote from one of the most incredible books I've ever read, The Art of Happiness, by His Holiness the Dalai Lama, who is a hero of mine. And in The Art of Happiness, His Holiness says, "The systematic training of the mind, the cultivation of happiness, the genuine inner transformation by deliberately selecting and focusing on positive mental states and challenging negative mental states, is possible because of the very structure and function of the brain. But the wiring in our brains is not static, not irrevocably fixed. Our brains are also adaptable. Now, this is a beautiful quote. For a start, the first half of the quote sounds like any philosopher or theologian talking about how we can transform our minds by thinking, we can become happy, etc. But it's the middle of the quote where His Holiness says that this is all possible because of the very structure and function of the brain. Because the Dalai Lama is very happy that scientists are addressing this issue of happiness. He doesn't think that it's necessarily just the realm of theology. He knows that science can help us as well. And in fact, he has a retinue of monks that talk to neuroscientists, neuropsychologists, and Western philosophers to understand this. And I think this is a very wonderful example of his ability to see that we can all contribute to our understanding of the human condition. And the final part of the quote is my favorite part, because he's acknowledging that our brains aren't static, they're not fixed, and they're adaptable. And we know this because of wonderful work that's been done on mindfulness meditation. Here we see on the left-hand side one of my very favorite photographs. It's a photograph of His Holiness, the 14th Buddha of Compassion, taking a photograph of someone going into a brain scanner. And this is because of his deep interest in mindfulness meditation and what that can help us understand about the brain. Now, mindfulness meditation is one of many different meditations. There's often a confusion about what meditation is and what it isn't, and some people think it's about clearing the mind, emptying the mind, etc., or chanting. That's generally about different types of meditation. But mindfulness meditation is a specific form that came out of Hindu and Buddhist philosophies of over 2,000 years ago, but has been synthesized into an 8-week course called the 8-week mindfulness meditation program. And it's got nothing to do with chanting or saffron robes or joss sticks or anything like that. It's a completely secular form of understanding how you can concentrate on the current moment, which is the state of being mindful. Now, very importantly, there's a lot of scientific data that backs up the efficacy or the usefulness of mindfulness meditation. There's been research that's shown that people who undergo this 8-week course, if they are candidates for heart surgery, there is a reduced relapse rate after the heart surgery, because before this, it was seen that many people who'd had heart surgery tended to have a relapse with another heart attack afterwards. But if they did the mindfulness, what tended to happen is that their likelihood of having another heart attack was reduced. It's also been used for helping people who've had more than 2 episodes of clinical depression. And actually, in the UK, the National Institute of Clinical Excellence actually recommends mindfulness-based cognitive therapy. So rather than just cognitive behavioral therapy or CBT, it actually recommends a component of mindfulness. It's also been used to help people who suffer from chronic pain, and amazingly, even people with skin complaints such as psoriasis. So what we can see is that this particular technique, mindfulness meditation, that comes out of these ancient Hindu philosophies, can actually have incredible impacts on our physical condition. One of my favorite studies was one where they had 2 groups of people, one of which did mindfulness meditation for 8 weeks, and the other group didn't do anything like the mindfulness. After the 8 weeks, everyone was given a flu vaccine, and the vaccine creates antibodies, which are basically ways of fighting future attacks of this particular illness, such as the flu. And so if you've got a strong immune system, your body is able to develop more antibodies. antibodies. And what was found is that the group that had done the mindfulness meditation, their bodies produced significantly more antibodies than the group that hadn't done the mindfulness. So what that shows is that the mindfulness seemed to have a direct impact on your health by improving your immune system to actually create more antibodies. So there are amazing consequences of the mindfulness. Then finally, we can see that it has direct impacts on the brain. In a beautiful study by Sarah Lazar in Massachusetts, she studied people who were long-term meditators, so people who'd been doing not just the 8-week course, but had been doing it for many years. And she compared them with people who've never done meditation, known as controls. And what we see in this graph here are our long-term meditators in the blue circles and the controls who've never done any meditation in the red squares. Now, taking the controls to begin with, we can see on the y-axis here is thickness of certain parts of the brain, and basically the thicker the brain, the thicker that part of the brain, the more efficient it is, because it means that it's healthy. And here we see age going from 20 down to 55. If we look at our controls, the red squares, what we see is bad news. That line is effectively what is happening in that part of the brain, and that's happening to all of us right now. We are losing brain cells, and that is just a natural part of growing older. And this might actually be contributing to some of those memory problems and dementias that I was talking about earlier. But the remarkable thing is that when you look at the meditators, we see this flat line. So what this seems to suggest, we can't prove it, but what it seems to suggest is that these people who've been meditating for many years, they're managing to protect themselves from this standard decline that is happening over time. So what we're seeing here is that these areas that are important for attention, which is our ability to look at information and filter information around us, sensation, so actually taking information in through our senses, and perception, which is our understanding of that information, that our ability is not decreasing if we do meditation. So if there's one thing that you want to take away from this talk, it's that you should go and start meditating, because it's never too late. The next thing I want to talk about is the fact that it's actually possible to help people who've had brain damage, like Nicola, but who've had different types of brain damage. And this is work that's being done by Pedro Douglass-Kirk, who is a wonderful young man who's been helping me with these talks, and he's doing his PhD on music and helping people who've had strokes, which has resulted in some sort of paralysis or semi-paralysis of an arm. And he's doing this as part of his PhD with one of my colleagues, Stewart. And what Pedro is looking at is the fact that when we're moving around and we're using our bodies in everyday life, there are certain aspects of the way we do things that involve good quality, which shows that the body is working properly. And if you're trying to pick up a cup from a table, then an important thing is that you extend your elbow fully. But if you do that badly, or rather if you aren't able to because of stroke, then what happens is that you don't move your elbow fully, you don't extend it, and you lean forward. And we know that that's not good for your posture, etc. And this is something that is known to happen after stroke. So what Pedro is doing is using the fact that we know that music is a real stimulator for people anyway, but it can particularly help people who've had strokes. So
some things just take you right back. You forget you've got to go soon.
What we see here is that Pedro's developed a system for looking at important points in the physical system. So the shoulder, the elbow, the wrist, where the chest is in relation to the table, which can tell us whether someone is upright or whether they're leaning forward, where that is relative to their face, so whether they're dipping their neck, etc. And by seeing these different coordinates, he's able to track the way someone is moving. Now, the way that he's developed this system is that the music that the person is listening to will continue playing if these coordinates are maintained for good posture. But if that doesn't happen and the person leans forward, which we know is bad posture, and they don't fully extend their elbow, then the music actually stops or slows down. And that is feedback to the person who's listening to the music, because they've chosen this music as their favorite music, and that's going to tell them, I need to change the way that I'm moving my body forward or my elbows. So here we go again.
She makes me go across. She makes me to lie down. Lie down and let the music play. Nothing in the way.
So you saw there that when Pedro leant forward, the music stopped, and that was telling him, I need to move back to my original position and I'll get my music. And so what they're finding in their research is that by using this system of using the music to give feedback about movement and posture, patients are slowly learning over time how to develop their correct posture, correct movement, correct elbow extension, etc. The final thing I want to talk about is giving people feeling back, because one of the things that happens with some people, unfortunately, is that if certain nerve fibers have been severed or damaged significantly, then the type of information that you're getting from your hands, your feet, the rest of your body just isn't going up to the brain. In this particular video, the video that I'm going to show you next, this young man, Nathan, who suffered a car crash, the lower part of his body is not able to communicate with his brain, and therefore, as a result of that, he can't feel anything in his arms, etc. What has been created by these scientists is a robotic arm which is going to feed information via this computer directly into Nathan's head, into that Alice band that I showed you in my brain scans, which is the area where we control our movement, but also where we feel information from the outside world. So whenever we feel information by touching something, that information is taken up into those areas. And what's going to happen is that this information from here is being relayed by this computer directly into Nathan's brain to give him feeling, because his arm here is not able to do that. So in the next video, the scientist is going to be touching these fingers while Nathan has got a blindfold, and he has to guess which of the fingers is being touched.
I'm good.
Okay, here we go again.
Index, ring, pinky, index, middle, middle, middle.
So what you see there is that Nathan is blindfolded, he can't see anything, his hand isn't even touching anything, but this robotic arm is being touched by the scientist, and because of the information that is being fed via this computer directly into Nathan's brain, he's able to work out which of those fingers is being touched. Now, this is obviously very preliminary research, but it's amazing because it means that for patients like Nathan, whose the spinal cord has been damaged such that he can't receive that information from the rest of his body, we can find ways to give him feeling back. And of course, it's a long journey, but it's a very exciting one to give people this feeling back that years ago was never going to be possible. The very final area that I want to talk about is an incredible area which is to do with communicating with someone who's in what's known as the vegetative state. And it's work that's done by this really remarkable man, a British scientist called Adrian Owen, who works now in Canada, started off in Cambridge, but now is in Canada. And he's been working with people who are known to suffer from what's called the vegetative state, where they aren't paralyzed, they can move around, and their eyes are open, but they're completely non-responsive. So if you ask them a question, they won't give you an answer. If you ask them to look at you, their eyes will wander randomly. If you put your hand in their hand and ask them to hold your hand or to squeeze it if they can hear you, nothing happens. So to all intents and purposes, they're completely non-responsive, and that's what's resulted in this term, the vegetative state, that they're like a vegetable. And Adrian has done this remarkable work to help us actually communicate with these people. What Adrian did was that he took people who don't have any brain damage, so we refer to them as controls in our research, and he said to people while they're in a brain scanner, I want you to imagine that you're playing tennis. And you remember the Alice band that I said is useful for moving, that is involved in moving our bodies. It's that area that goes either side of our heads, like this Alice band, and it's this area here, which is in a cross-section of the brain. Now, what we find is that if I asked you, whilst you're in a brain scanner, just to pretend that you're playing tennis, then this part of the brain starts becoming active, and in this brain image what we see is it's shown in the reds and oranges. If I ask you to imagine that you're walking around your house, so something that doesn't involve tennis but just walking around your own home, your apartment, your home, a very different part of the brain lights up or becomes active. It's this area here called the hippocampus. So this area called the motor cortex, and this is an area here called the hippocampal area. Now, the reason that's important, that we know this in healthy people, is that Adrian took people who are completely unresponsive to either having their hand held, being spoken to, etc. He put them in a brain scanner, and he said to them, I want you to pretend that you're playing tennis. And guess what? The same part of the brain became active in these patients as in your eye. So even though the patient doesn't respond when you say, can you hear me? There's no response, they don't hold your hand, they don't squeeze your hand, they don't move their eyes in a particular direction. When you say, I just want you to pretend that you're playing tennis, the same part of the brain becomes active. When you ask them to imagine they're walking around their house, again, the same part of the brain that's active in you and I becomes active in these people. What Adrian did next was a really remarkable, beautiful and clever piece of science. He then said to these patients, because in fact he's not interested in these people playing tennis or walking around their houses, he wanted to locate two areas of the brain that he could use to communicate with these people. So this is why we get the yes and no. He said to the patient, every time you want to say yes to any question that I ask you, imagine that you're playing tennis. So, for example, if I said to you, is 2 plus 2 4, and you wanted to say yes, I'd want you to imagine you're playing tennis because you can't speak to me. If you want to say no, if I say, is 2 plus 2 5, you'd want to say no, then you would imagine that you're walking around your house. And so what Adrian has done is that he's used walking around, playing tennis as a substitute for saying yes, because he knows which part of the brain becomes active here, and saying no becomes walking around the house. So he's created these two responses, walking around the house, playing tennis. He then used that to actually communicate with these patients. So he was able to ask them questions like whether they could hear him, whether they were in pain, whether the room in the hospital was too warm, too cold, etc. And having tested out the system by asking questions that he knew the answers to, such as the patient's father's name, etc., he was able to directly communicate with these patients. And some of these patients, after years of the vegetative state, eventually came out of the vegetative state, and they were able to say that they could always hear Adrian when he was talking. Now, this is really important because here's a quote from The Independent that the terrifying reality of being trapped inside your own body, in your own world, was underlined by a letter he received from one patient years after she regained consciousness. The woman in her 20s wrote, "Please use my case to show people how important the scans are. I was unresponsive and looked hopeless, but the scan showed people I was in there. It was like magic. It found me." Now, this is important because, of course, one of the important things in cases like this, when someone is completely responsive, is about whether to withdraw life systems that are helping the person breathe, etc. So important for cases of end of life, which is obviously a huge ethical issue. If you're interested in Adrian's work, then this is a book that he's written, a remarkable book called Into the Grey Zone, and I'd highly recommend it for this really remarkable man by this amazing person. A really remarkable work by this amazing man. Finally, I just want to tell you about studies that my own group is doing in case you're interested in getting in touch with us to become involved, because some of our research can be done online, so it doesn't matter whether you're in Mexico, Kazakhstan, anywhere in the world, you can contribute to our research. We do research on face recognition and that condition prosopagnosia, on memory and amnesia, on dementia with our research on our new test, the VALMT, on stroke rehabilitation, and this is the work that Pedro is doing, and then in the area of executive functions, which is the brain of the brain, and that's going to be the focus of another talk that I'll be giving. If you'd like to take part in our research or want to know anything more about our research, then please get in touch with us. You can email either of those, although the first of the two addresses, Claudia's, so c.pulcini@goal.ac.uk, is the one to write to us. So please do get in touch with us. Finally, if you remember, I gave you that cheeky video from The Life of Brian, the Monty Python film. Now, why did I do that? Here is a timeline from 1000 BC to today. So we know that about 3000 years ago or more, the ancient Egyptians had written down a word for for brain. 1000 years later, Christ was born. 1000 years after that, there was the Norman conquest of Britain. And then today, here we are with the coronavirus, which is the reason that I've started giving these talks online, because I wasn't able to give them in person. What we have here is a 3000-year history Now, not everyone's very good with numbers, so what I'm going to imagine is that this is actually 30 years. So I'm going to divide all numbers by 100 to just make these numbers a tiny bit easier to understand. And I'm going to imagine that this 30-year time period represents a man called Brian. And I'm going to chart his history from when he was born, 30 years ago, when the hieroglyphic was written down, to today with the coronavirus. Now, before I tell you about Brian, I'm going to tell you about his older brother, Science, because science has been around for a bit longer than any understanding of Brian's life. And the reason I want to do this is to highlight where we are in our journey in the life of Brian. So let's look at the life of Science. When Brian was 5 years old, Pythagoras developed this theorem about right-angled triangles. Now, although it might have given you a bit of pain as a school child, that particular theorem is extremely important because it's the one that's important for understanding how walls can be kept up, how bridges can be kept up, all sorts of structures can be kept vertical. So Pythagoras did this when Brian was 5 years old. When Brian was 11, Ptolemy in Egypt developed an understanding of the universe and where the different planets were in relation to the Earth. Now, this is the ancient Ptolemaic universe where the Earth was in the center, the moon went round it, Mercury, then Venus, then the sun, etc. So, although this is not completely accurate, a lot of it is actually quite accurate in terms of Saturn being further than Jupiter, Mercury being further than Venus, etc. So this understanding was already there when Brian was 11 years old. When Brian was 22, Cambridge University, the best university in the world, was founded, and that is King's College, Cambridge, which is where I studied. When Brian was 25 years old, Copernicus did this revolutionary thing where he revised what Ptolemy had said many years before, and he said, no, the Earth is not at the center of the universe, it's actually the sun. So he put the sun at the center of the universe, and then all of the other planets are going in concentric circles around the sun, and this revolutionized our understanding of the cosmos. It got Copernicus into trouble because this went against theology and the idea of the Earth being at the center of everything, and he was in bad trouble with the church for a while, but he was right. When Brian was 26, Harvey, who was a physician, he charted our blood system, which is vitally important for understanding the blood flow around the body, what to do when we're ill, etc. And this did happen in Cambridge. When Brian was 27, also in Cambridge, Isaac Newton had an apple fall on his head, and from that he came up with the theory of gravity, which is vitally important for helping us understand why we're not all flying off into space. When Brian was 28 and a half, Darwin, who'd also studied in Cambridge, developed his amazing idea of evolution and how we evolved from the other great apes. When Brian was 29, Einstein developed his theory of relativity, which again took us to the next step of understanding the universe and things to do with the origins of our planet. When Brian was 29 and a half, Watson and Crick, again in Cambridge, were able to decode the building blocks of life, DNA. When Brian was 29 years and 7 months, so just 5 months ago, we landed on the moon and therefore are able to explore the universe. So what we see here is that in the life of science, a lot has happened while Brian has been alive. So what's happened in the life of Brian? Well, we know that he was born 30 years ago. Well, nothing happened for 28 and a half years that has helped us understand the brain, or Brian, until Broca worked with his patient Tan famously in Paris. And this is the brain of that patient who could no longer speak, and Broca came up with this revolutionary idea that certain parts of the brain do different things, such as speaking, remembering, seeing, etc. And that work by Broca, when Brian was 28 and a half, revolutionized our understanding of the brain. Psychology as a field started when Brian was 28 and 8 months, when William James started talking about our thinking processes, and that's when psychology was effectively founded. Cognitive neuropsychology, which is the field that I work in and which is the one that I've been talking to you about, was born 4 months ago when a group of neuropsychologists in Cambridge started saying, why don't we look at these patients with amnesia or prosopagnosia or the language problems as a mirror onto ourselves. We can try to understand the problems that these people are experiencing for trying to understand which part of the jigsaw they're missing. And by understanding, for example, Broca's patient who couldn't speak, we can understand this part of the jigsaw. And by understanding another patient who's got a different type of language problem, we can understand this piece. And by doing that around the jigsaw, by studying different patients with different types of language problems, we can understand how ordinary intact language works. By doing that with patients with memory problems, we can understand one piece from one patient here, like Nicola. We might have a different patient with a different memory problem, and we study them to understand this piece. So cognitive neuropsychology is this attempt to recreate this jigsaw by studying people with brain damage who've lost one piece of the jigsaw. Neuropsychological rehabilitation is this exciting new field which is of trying to help people with brain damage. So the research that I showed you with Nicola, where we taught her to use the palm top, that is an example of neuropsychological rehabilitation, where we're trying to help her memory system by developing new skills. Now, this is a photograph from Uluru, known as Ayers Rock, but Uluru is the original Aboriginal name, and this is the Red Mountain in Australia. And what you see here is what looks like a human skull, a cross-section of the face with the nose, the mouth, the chin, and the head, and a cross-section of the brain. Now, this photograph is from 2 weeks ago in Brian's life. I took it when I was at Uluru for the very first ever neuropsychological rehabilitation conference, where people who work with patients like Nicola, David, Philip, etc., came together to say, okay, we've been studying these people, we're understanding things about what they can't do, but we're also able to understand things that they can do, and we're now developing ways to help them, so rehabilitation. And that happened only 2 weeks ago in this 30-year-old life. The point of me making that statement is that our understanding of the human brain is really new. So cognitive neuropsychology, as I said, is only 4 weeks old in this whole journey that we're creating, or we've created, and rehabilitation is literally only 2 weeks old in this 30-year-old life. So what that means is that in our understanding of the human brain, we're like a baby crawling in the dark. It's a very new area. It's a very exciting one, but it's going to take us a long time to be able to do more work and to understand and to help people with brain damage. It's an exciting field, and I, for one, am very grateful for working in it. Thank you very much for listening into this talk. You can see my web address there, if you are someone who tweets on Twitter, then I'd really appreciate it if you could tweet about this and hashtag me as the brain guy. If you want to participate in any of my research, then please do get in touch with us either at this email address or the one for Claudia, which is c.pulcini@gold.ac.uk. We've got other videos of talks that I've given on YouTube. Please follow that channel by subscribing, and do feel free to get in touch with me. So now I'm going to start taking in questions that have been coming in from different people. So they're going to be in a bit of a random order, but here we go. So Osam Hummel from the States has asked, did Adrian Owen ask the vegetative patients if they were happy? Really interesting question, and I'm afraid I don't know the answer to that. Again, this is quite an important ethical question, and I don't know what the answer is. The interesting thing is that some people are emerging from the vegetative state. Not everyone, but some people. And the work that Adrian is doing is trying to look at how you can predict who will come out of the vegetative state, because if there are markers there that demonstrate how someone can come out, then it's extremely important that we're listening to what these people are trying to say. As you can imagine, the fact that the questions can only be yes, no type questions makes it a bit more difficult. You can't ask complex questions, but that's more about trying to find methods of asking the questions. The next question is, I'm sorry if I say this incorrectly, but Linguin EM asks, what is the no area of the brain called? In Adrian's work. Yes, well, that area is, as far as I know, there's an area called the hippocampus, which is in this area over here, a bit further in. That area of the brain is important in our spatial navigation. And if you remember, I talked about the London taxi drivers last week. That's the area of the brain that's important for spatially navigating around the world. There's also an area up here, kind of where the bump bit or corner bit is, called the parietal lobes, and that area is extremely important in our sense of where we are in a 3D world. So the parietal lobes and the hippocampus are those main areas. Okay, let's see what the next question is that we've got. One question is it true that someone can have amnesia and lose all sense of who they are? That's an interesting question, because the answer is actually no. The Hollywood idea of someone getting a knock on the head and waking up and not knowing who they are, etc., is complete rubbish. The person's sense of who they are is still intact. Their ability to speak English or their own language, etc., is still intact. They'll be able to remember some things from their past life, etc. That's something that varies between different patients depending on the extent of their brain damage, but it's certainly not the case that they're wiped. So there are forms of memory problems where someone goes into a complete shutdown. That's known as a psychogenic fugue, and that's more to do with an emotional shutdown because the mind is traumatized, and this can happen. But as I said, that's more of an emotional shutdown, but it's not to do with amnesia as such. It's a more of a protective thing that the psyche is doing, but that's very, very complicated, and it's not an area that I profess to know much about. Okay, so the next question. Oh, the question is that meditation raised antibodies in the immune system. Does that suggest that illnesses are psychosomatic? No, it doesn't. The fact that meditation can improve your antibodies and your immune system does not mean that depressed immune systems are psychosomatic. It just means that one way of improving the immune system can be through mindfulness meditation, but it doesn't tell us anything whatsoever that other illnesses are psychosomatic. Those have got physical causes, and they should be taken seriously. Okay, the next question is, how is the robotic arm attached to the brain? Nice question. The way that this is done, as far as I know, is that the area that is responsible for moving your arm and taking the information into the brain is near the surface of the brain. It's not right on the surface, but it's not deep inside the brain. It's near the outer bits. And so what they would probably do is, I've seen a brain surgery happening, and what they would do is to shave that part of the head. Then they would cut into the skin area, and then they would drill a part of the skull off so that they can reveal the brain. And then what they would do is place sensors directly onto the brain surface into the areas that they know are attached to the arm. This is extremely complex work, as you can imagine, but it's after finding out which exact part of the brain is responsible for the arm area, the finger areas, etc., etc. But that is something that through studying the nervous system, etc., it's possible to understand the kind of physical plumbing to know how the nerves and different parts of the brain are connected to the outside world, or to the arm at least. And so the sensors are put onto those areas so that information can be fed directly to those areas. Okay, so let's see, here's a long question from Paula Morris, sorry. Let me read it out. Noting the research demonstrating that those in vegetative states can potentially communicate using alternative means to identify the response, does that raise ethical questions with the removal of life-preserving treatment in those who would normally be deemed brain damage to the extent that feeding or breathing should be removed? Absolutely. And so just to summarize, what Paul is asking there is, given that we know from the work of people like Adrian that these people who are not responsive to verbal commands, to someone holding their hand, etc., etc., given that they're not responsive, but we now know from the work of people like Adrian, and the fact that some of these people emerge from the vegetative state, it doesn't have to be permanent. Does that have ethical implications for end-of-life care and removing the life support, etc.? Hugely. And when I saw Adrian speak last year in New York, he said that he knows that there are massive ethical implications of his work, but he doesn't want to go into those areas because his job as a neuroscientist isn't to answer those questions. Those questions are for people who work in medical ethics. But it certainly does suggest that just because someone is not responsive does not mean that they can't respond. And I think that that's the most beautiful aspect of his research, that it means that they can't respond in the way that we're used to, but there is a response going on. And I think that that is the most crucial thing about his work. Okay, next question. Let me see. So Jonathan Gossage, I think, says, do the results of these experiments indicate that the auditory system is still working? Has there been an attempt to try these experiments using visual input? That's an interesting question, Jonathan. To be honest, I don't know the answer to that. I would only conjecture that given that with some patients, with other types of disorder where there's paralysis, but they can move facial muscles or their eyes. The clinicians can ask those people to move their eyes to the right, let's say, to say yes, and to the left to say no, etc. But we know that people in vegetative states can't do that, because if you ask them to do that, that doesn't happen. There's a famous book called I think it's The Diving Bell and the Butterfly, or something like that, about someone who wrote a book just with eye movements because he was paralyzed. And it is possible, but I think the fact that this isn't being used in these patients suggests that that isn't possible. But I think it's an interesting question, and I'm hoping to get in touch with Adrian at some point. So I'll see if I remember that question and ask him for you. Oh, here's one of those corkers. Priyanka Day asks, is the mind the same as the brain? As in, when we refer to the human mind, are we referring to the human brain, or is it different? That's quite a question. I think the brain is the physical substrate. The mind is the idea of who I am right now, and the way that I'm thinking, and the way that I'm able to respond to you, which is separate from the brain. And that separation is one that is really making people think a lot, making people argue a lot. But I would say that the brain is the physical noodle that we've seen. I've shown you brain scans, etc. Whereas the mind is how the information is processed within that physical jelly, and allows me to be me, allows my twin to be a separate person, etc. So I think the mind is the collection of experiences, etc., that are brought about on that physical substrate. Okay, the next question is, this question is from Lauren Kelly, which is that I've heard that there have been multiple people that have woken up from a vegetative state having learned a new language somehow. Could you explain how this happened, or is this just a myth? I'm afraid, Lauren, as far as I know, that is a myth. There are people who come out of some forms of brain damage and start speaking with a different accent, and that's known as foreign accent syndrome. And there is some scientific work on that, but the idea of someone waking up speaking a completely different language, I've never heard of that, and I would be surprised at how that is possible. I'm not saying it doesn't happen, but I've never heard of it, and I can't see how that would be likely. Okay, Sam Hummel asks, you used the metaphor of the broken car in the last presentation to explain how we're learning about parts of the brain by studying people with brain problems. I'm curious if there is similar work studying people with super brains that are able to perform some tasks at the abnormal high level. If so, what's the field of research called, and what are the most exciting things coming out of that field? Thank you, Sam. The interesting question. So yes, this dovetails into an interesting issue to do with research psychology. After the Second World War, because of all the shit that happened, there was a huge focus in behavioral psychology to try to understand the shit that happened. Why do people treat each other so badly? What is authoritarianism about, etc. There's all the negativity came out of the war, mental health problems, etc. So people wanted to understand that. So there was a big focus on understanding the negative aspects of, or the darker aspects of human psychology. But more recently, in the last 20 or so years, a new movement called positive psychology has sprung up, which is that, yes, we know that there are these negative aspects, but not everyone behaves like that. So there are positives as well. So this is an overall field called positive psychology. And I think in cognitive neuropsychology, we're kind of coming to the same thing, that it's easier to see something not working than seeing something that's working really well. So if I take you back to the example of prosopagnosia, it's easier to see when someone cannot recognize faces than when someone is really good at recognizing faces. And in fact, the research on super recognition, so that's extremely good recognition of human faces, came about because of an advert that was put out somewhere to try to find people who couldn't recognize faces. And some people wrote in and said, I'm actually quite the opposite. So we are doing work on that, and we're trying to understand some of that. There's also work on people who are exceptionally good at memory, people who are good at recognizing people from voices. Now, one of the issues within that, which I think is quite interesting and isn't really addressed, is the fact that in reality, those examples like super recognition or these people with these super memories, they're simply just at what we call the tail ends of our normal distribution, or that bell-shaped curve. So using the example of running, as I did last time, some people can run, but they're very average. Some people are not as good and they're below average, and some people are better than average. And then there's some people who are super above average, and they're the ones that we put medals around every 4 years or so. Now, does that make them a separate type of human being, or does that just make them a human being with a running machine, with a running system, which is just a very, very good one? Just like there are people who've got really good eyesight, people who are really good at playing the violin. Would we say that those are different type of human beings, or are they just human beings who are at the high end of a normal distribution? And so I think that this question is an interesting one because it goes to the heart of the types of conclusions that we can make from people who are that different. The reason that cognitive neuropsychology and the study of people with brain damage is interesting is because these people like Nicola, David, Philip, etc., they were like everyone else. They were Joe Bloggs or John Doe. They were in the middle of the curve, and they could recognize, they could remember, they could recognize animals, etc. Just average. They were fine, but there wasn't anything remarkable about them. And all we're doing by studying them is to try to infer how the normal healthy system works. And I think that from the perspective of understanding how you and I function, it's better to try to understand someone who's in the middle of the bell curve than someone who's exceptionally good at something. Because trying to study how finger movement works by studying a virtuoso violinist might not really tell us how your fingers work. And so I think that there is something interesting there, that studying brain damage gives us a window onto the healthy, normal, average system in a way that studying people who are exceptionally good doesn't. But that's just my opinion. Okay, next question. Oh, apparently the book, I got it wrong about the person who wrote the book with eye movement. It's called The Diving Bell and the Butterfly by Jean-Dominique Bauby, and the surname is spelled B-A-U-B-Y. So that's The Diving Bell and the Butterfly. Okay, so the next question is from Sue Tyree, which is that in what ways, if at all, does the work you have described that is being done now relate to work done some years ago by a guy called van der Valk on traumatic memory. It's not related to that, I'm afraid. The work on traumatic memory is that psychogenic amnesia that I was referring to, which is about, not about brain damage, but it's about psychological defense systems that the brain has developed to shut out information that it can't currently process. In the way that if you're feeling really rubbish, you don't want to think about something, you can consciously do that. But with the psychogenic cases and with these traumatic amnesias, it's an unconscious system that's taken over because the experiences are so traumatic. It's not understood well, and I certainly have never worked in that area because I think it's extremely complex. So no, the work that I've been doing is on organic amnesia. So that's amnesia that's been caused by an organic cause, such as the viral encephalitis that unfortunately Nicholas suffered from, or from temporal lobectomies, brain surgery, or from strokes, etc., but not from a psychological shutdown of the system. Okay. So Sam is very busy here. He said that there's someone called Jim Quick who's trained himself from one edge of the bell curve to the other, had a memory brain deficiency as a child, and taught himself to be a top memory and brain performer in the world. Yes, there are. That's an interesting thing. This is about whether you can train people to have better memories. Yes and no. Yes, it's possible to train someone to remember the 42 cards in a deck of cards and to remember all the objects that are in this room. Those are memory techniques, and they're good tricks to learn. In terms of whether they translate to everyday memory, that's a separate issue. So yes, it is possible to train someone to remember a list of words perfectly. But whether that translates to actually having a good memory for the conversation I'm having with you right now, or remembering someone's face, or seeing a visual scene, remembering music that you've heard, that I don't know. So I think there is a difference between getting really good at a memory technique and having a good memory. I think those do differ. I haven't done work on it, but that's what I would suggest. Okay. So Shileka Roy Basu has asked whether mindfulness meditation is also effective for dementia. That's a very interesting question, and I don't know the work that's been done with dementia for mindfulness. I would hazard a guess and say that it might have minimal benefits, some benefits, but not full benefits. And the reason for that is because the impact of mindfulness meditation, as far as I know, is mainly in the front part of the brain and in the control of our attention and in the way that we perceive information. So when I say control of attention, if I'm talking to you and I start thinking about something really negative and that makes me lose concentration on what I'm talking to you about, that is a form of mindlessness, where I'm letting my mind wander rather than sticking on the conversation that I'm having with you. Mindfulness is the ability to not let the mind wander and to stay on task and focus on the thing that I'm doing right now, which is breathing and talking to you. Now, the reason that is improved is because it's probably having an impact on the front of the brain, which is the control centers of the brain, which is where attention is housed. And so attention is our ability to move our attention from our body to our breath, to our hearing, etc., etc. Now, dementias are very complicated. Dementia isn't one thing. Dementia is a broad umbrella term for lots of different types of degenerative disorders. And Alzheimer's is the best known one, but there's other dementias, there's frontotemporal dementia, vascular dementia, etc. Now, all of these are having impact on multiple brain areas. So if they're having impacts on multiple brain areas and the mindfulness is having an impact mainly on the front of the brain, that's going to have an impact on certain cognitive abilities, but I can't imagine that it's going to have an impact on some of those other systems. But I think it's an important question, and a new friend of mine, Katie Holmes, who is listening in, I think, a friend of Meryl Butters, she does work on mindfulness in brain disorders, so I'll try to find out that answer from her. Okay, I have now run out of questions to answer unless let's see, I think there's some more questions. No, these are the same questions I've already received. I think I've got answered all the questions that I have received. If you have any questions, then please do let me know. I'm really happy to do more talks like this. As I said, Lofty, and happy birthday again, Lofty. Lofty has been helping me, suggested this just a couple of weeks ago because of COVID and the lockdown, and he and I were going to organize some talks here in our local area, hiring a place and letting people come and listen to my talks. And then the lockdown happened, and so we couldn't hire a place. And Lofty, being the lovely, positive, creative person that he is, suggested that we just go online. So that's how it all came about. Now, I'm only just getting into this online talking thing, as you can tell, because I'm still trying to get some things right. But I love educating people about the brain. And so if you're listening and you would like me to give more talks, then please do write in. I do have some other talks up my sleeve that I'm preparing to give, but it would be really interesting to hear what types of talks you guys would like me to give. I can give talks like this, which have taken more than 30 minutes, I'm sorry, but I hope it's been interesting. But I can also give shorter talks on smaller subjects. So please do email me and email my research team with your questions, because we would love to hear from you, and we'd love to have your participation in our research, and we would be happy to develop more talks to give to you. So I will be announcing any future talks, maybe next week, about face recognition or maybe even amnesia. I'll see how I'm feeling, and I'll see what sort of feedback that I get. So please do let us know what you thought about the talks. That will help us to develop further talks, whether you want them or not. Let us know what types of talks you would like, and we will see what we can do. Let's assume that there's going to be another talk. We don't know what it's going to be on, but there will be something. So thank you very much. I'm really pleased that you've tuned in to listen, and look after yourselves. Goodbye.